Hey everybody, welcome to 8.6, the Law of Sines and Law of Cosines notes. In this video, I'm going to go over, obviously, the Law of Sines and Cosines, but how it's used is it's basically used in non-right triangles. So in the past two sections, we've done lots of trigonometry, but it's been specifically for right triangles. And so you can use trig whenever you have any type of triangle. And so these kind of, formulas help you do just that. So up top I have the definitions from the book and the formulas as well. And it says the law of sines can be used to find the side lengths and angle measures for any triangle. You can also use the law of sines to solve a triangle if you know the measures of two angles and any side, meaning an angle side kind of pattern or an angle side angle kind of pattern. And so this is the law of sines right here. So let me zoom in on it. And it says if triangle ABC has lengths A, B, and C representing the lengths of the sides opposite of the angles with measures A, B, and C, then sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. So the corresponding angle is always opposite of the side. So here's angle A. If you draw a line from A, it goes to the side A. B, draw a line opposite of it. There's B. C, opposite of it. There's C. Alright, so that's how you kind of figure out your angles and sides. And of course, we'll get to that on our examples. But the definition for law of sines says you can use the law of sines to solve a triangle if you know the measures of two sides and an included angle. So side angle side style. So law of sines is used for these other two, and then if it's a side angle side style, you're going to use the law of cosines. And the law of cosines is actually kind of it is derivative of the Pythagorean theorem. So you see how it says like a squared equals b squared plus c squared minus 2bc cosine a. So this, this first part obviously looks a lot similar to the Pythagorean theorem, and then this looks brand new. But yeah, it's basically just a formula that we're going to use, and you just kind of use based off of what you're looking for and slash what you're given, okay? So yeah, that's what we're going to go over in these examples here. So for example 1 here, I'm going to solve for x, the missing side length of AB, and I'm going to round my answer to the nearest thousandths place. So looking at our picture with what we're given an angle, and then a side, and obviously we're looking for an x. But since we're given an angle, and a side, we're going to use the law of sines, because in the definition I read you a moment ago, law of sines can be used for angle, side type triangles, or whenever you're given information like that. And so the law of sines tells us that the angle is opposite of the side it is to be associated with. So angle A is 97 degrees. So I'm going to label this 16 as a lowercase a. And then angle 21 is in the pocket of letter C, and it's opposite of the x. So I'm going to label the x as the little c side. And so the law of sine says do sine of the angle, so sine of like 97, over the side length that it's opposite of, so 16, and set that equal to the other sine of the angle, so sine of 21, and put that over the other side that it's associated with. So that would be the c side, which we don't know what it is, so I'm going to put the x there. And now we just have a simple proportion. And so, proportions can be done by cross multiplying the two numbers and then dividing by that third number. So essentially we have 16 times sine of 21. So I'm going to literally write down x equals 16 sine of 21. And then I'm going to end up dividing it by sine of 97. And so you can actually type this into your Desmos or scientific calculator, obviously without the x equals. Just type in 16 sine 21 divided by sine of 97, and you'll get 5.7769, and so if we're rounding to the nearest thousandths place, that'll be 5.777, and that's the length of the missing side x. So in this one, I'm given an angle, then a side, and then another angle, and I'm going to use that information to figure out x. So look at what you're given, angle, side, angle. You can use the law of sines again because the law of sines can be used for angle, angle, side, or angle, side, angle when you know two angles on one of the sides. So the 45-degree will be associated with the x. The 73-degree will be associated with, well, we don't know what to put there. But think about it. All the angles in a triangle add up to 180, right? So doing 180 minus 45 and minus 73 will get us to figure out what angle K is. And that's 62 degrees. And so if you're lost as to why am I doing that, well, if this is 62 degrees, that angle is opposite of that 10 right there. So I can use the 62 and the 10. So I don't have to worry about trying to figure out what this side is, because since I knew two of the other angles, I could just take those away from 180, figure out this, and so now I can just go and use the law of sines. I don't have to make it more complicated than it needs to be. So I'm going to do sine of 45 over x, and then I'm going to set that equal to sine of 62 over 10. So once we have it set up, you cross multiply. So now we're going to do sine of 45 times 10, and then we'll divide that by sine of 62. So x equals 10 times sine of 45. Whenever you multiply a number by sine, cosine, or tangent, you want to put that out in front. All right, and then we're dividing it by sine of 62. And we'll type that into our calculator and round it to the nearest thousandths place. I get 8.0084, so that'll just stay 8.008. And that is the length of our missing side. So whenever you're doing these, the sides should sound, reasonable in comparison with the other sides. If it's way bigger or way smaller, maybe you made a mistake, maybe not. But I like to always think back to what I'm given with and see if it makes sense. Like if I have a side that's 10 and I have another side that's 8 something, that should make sense. Yeah. So hope that helped. Okay, in this next example, we are given a side, an angle, and another side. So if we're given a side, angle, and a side to find x, then we must use the law of cosines, because the law of cosines needs to be used whenever you're doing side, angle, side. Okay, so next let's label our sides and how they relate to our angles. So 28 is in the pocket of C, so the x is going to be the little c side. And then it looks like B is across from the 11, so this will be little b. And then that means 9 is across from the A, so that'll be the little a side. So here's our formulas again. And so since x is with the little c side, I'm solving for that. I'm going to do this formula right here. So let's plug in everything we know. Okay, since the little c was x, I have c squared equals x squared equals, and then it said a squared plus b squared, so 9 squared plus 11 squared, minus 2ab, so minus 2 times 9 times 11, times cosine of c, angle c, so times cosine of 28 degrees. So what we should do now is just kind of simplify all these other numbers. So I'll get this number in front of the cosine, I'll add together 9 squared plus 11 squared. And so that gives me x squared equal to 202 minus 198 times cosine of 28 degrees. And so when you're solving for x and you have an x squared, how do you get rid of a power of 2? You take the square root of both sides. So yeah, it seems kind of weird, but you're going to take the square root of this entire side. So in your calculator, you're going to type in the square root of this whole expression right here. But that'll give you your answer. So I get x is going to be approximately equal to 5.2 130,966. So just round it to the nearest thousands place, 5.213. And so yeah, that's basically it for that one. So in this next example, I'm given side, side, side. I have three sides and I need to figure out x. And I should have mentioned it in the law of cosines definition, but you can use law of cosines for side, angle, side, and side, side, side. I neglected to mention that at the beginning of the video, so um, self note to add that into my definition later. But yeah, I'm going to use the law of cosines here. And so since our formulas are in terms of A, B, and C, if you want to just like re-alphabetize your letters, that's fine. We just need to make sure we go, I guess, in alphabetical order. So L, M, N, O, P. So M is going to be the A. N, O, P is going to be the B. And then Q, R, S, that's the last letter, will be the letter C. That means 8, it will be the little a, and 6 will be the little b, and then 3 will be the little c. So we're looking for angle A, right? So we're going to want to use the a squared one since, you know, A is going to be associated with angle A. And then we'll have to go backwards a little bit, but I'm going to use this formula right here. Okay, so plugging everything in, I got 8 squared for a squared equals b squared, that's 6 squared, plus c squared, that's 3 squared, minus 2bc, so 2 times 6 times 3, times cosine of x degrees. So the next step would be to simplify everything. So instead of writing 36 plus 9, I could scratch that out and just do that math right now. 36 plus 9 is 45. But obviously I got the 36 plus 9 from doing the 6 squared minus 3 squared. And then 2 times 6 is 12, and 12 times 3 is 36. So that's how I got 36 cosine x degrees. And so in this one, I'm not going to square root both sides. That's not going to help because I don't have an x squared equals whatever on the other side. So what I can do here is I can actually subtract the 45 to the other side to the 64, right? And 64 minus 45 is going to give me 19. So now I have 19 equals negative 36 cosine of x degrees. And so I think a lot of kids, when they look at problems like this, they can get very confused or intimidated. Just pretend cosine of x, it's one singular term. I mean, it really is. So just pretend cosine of x is like x, and you're just solving a regular algebra problem. Here you have 19 equals negative 36x. So what would you do to get rid of the negative 36? Since it's tied in to the cosine of x, it's multiplying by it. So the opposite of multiplying would be to divide both sides by negative 36. So don't make the mistake of adding the 36 to the other side. You want to divide it to the other side because it's currently multiplying by the cosine of x. And so by doing that, we will now have 19 over negative 36 equal to cosine of x, and we'll be almost done. Okay, so now, how do you finish this problem? Well, think back to the definition of sine, cosine, and tangent, and specifically just think back to the definition of cosine. Cosine is adjacent over hypotenuse. Here we have a fraction equal to cosine of x. And so if you think about it, you can treat 19 as your adjacent and your negative 36 as your hypotenuse, and that would be equal to your cosine. So whenever you do normal, sine, cosine, and tangent, you know the angle and you are solving for a side length. Here I know my two side lengths. So that means we're going to have to do inverse sine, cosine, or tangent, or inverse cosine in this example, because we know our side lengths and we're looking for an angle. So whenever you have a problem like this and you know what's on the other side of the equal sign, but you do not know the degree that should go into that trig function, then pretty much all you have to do is flip things around and put the fraction in the parentheses. Just remember, you're not doing regular cosine anymore. You're doing inverse cosine. So yes, you can magically, if you think about it, you can magically flip things around, but really you're doing inverse cosine. So that's inverse is opposite of regular. So if you're moving things to the opposite side, you're still doing the opposite operation if you think about it. So yeah, I think I'm over explaining at this point. So really, just you can flip things by doing the inverse. So inverse cosine of 19 over negative 36 will equal x degrees. We just need to type that into our calculator and get the answer. And when I do that, I get x equals approximately 121.855 degrees. Or I guess about 122 degrees. But I've been rounding all these to the nearest thousandths place, so I might as well just keep doing that. So for my final example, I'm going to find all the missing angles, and I'll, keep rounding each angle to the nearest thousandths place. So here I'm given side, 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 which means I have to use the law of cosines again. And then let's just label each side. The 15's across from angle A, so that'll be the little a. The 12's across from the B, so that'll be the little b. And 13's across from the C angle, so 13 will be the little c. So when you think back to your formulas, it doesn't really matter which one you choose to start with because we do not know any of the angles. And so just because I've used the a squared formula and the c squared formula, I'm going to go ahead and start off with the b squared formula and then solve the problem from there. So using my numbers for the a, b, and c and the b squared formula, I have 12 squared equal to 15 squared plus 13 squared minus 2 times 15 times 13, because I'm using those numbers for the a and c, times cosine of b. So now, right now, I just need to evaluate and combine like terms with these numbers and then multiply all these numbers together. So 15 squared is 225 plus 13 squared, that's 169. Add those together, you get 394. Do negative 2 times 15, that's negative 30, times 13, that's going to give you negative 390. And then, of course, don't forget about the cosine of b. So just like the last example, I'm going to minus 394 to the other side. And I get negative 250 equal to negative 390 cosine of b. So the next step would be to divide both sides by negative 390. And so my fraction of negative 250 over negative 390 can simplify. The negatives would cancel, and then 250 over 390 would simplify to get 25 over 39. And then that's going to equal cosine of angle B. And so remember, you can just turn that into an inverse problem. So do inverse cosine, of 25 over 39. And then that's going to give you angle B. And so you just got to type that into your calculator and round to the nearest thousandths place. I got 50.1316, so that'll round to 50.132 degrees. So moving forward to solve for the other angles, I'm actually going to go and use the law of sines. You got two options. You can use your rounded angle measure, or if you don't want to round and you want to get a more precise answer, which is what I'm going to do, I'm going to use inverse cosine of 25 over 39 anytime I'm going to use angle B. So just be forewarned, I'll write that for my angle B degrees, but to figure out the other angles, I'm going to use this value because it's more accurate, because it's not a rounded value. So looking at our picture, we need to figure out angle A and angle C. It doesn't matter which one we choose to do. I say let's go alphabetical and let's figure out angle A next. And so when you know two sides in an angle, you can use the law of sines. I think it's a little quicker than doing the law of cosines, and especially when you do not know the angle. The law of cosines, as you could tell from the earlier example, is rather quick when you know the angle, but when you don't know the angle, it does take extra work. So that's why I'm going to do the law of sines next, because once you know one angle and you know two of the sides, do law of sines. It's much quicker. So I'm going to do the sine of 50.132, or like I said, the inverse cosine of 25 over 39 over 12. And then I'll set that equal to sine of a over 15. So here it is set up, and like I said earlier, I am using the inverse cosine of 25 over 39 instead of the 50.132 because it is more accurate. As long as you're using the parentheses in the correct way, your calculator can and will handle it. And so here I'm going to cross multiply and divide like I did in the first two examples. So here I have 15 of sine, cosine, all that stuff. And then I'm going to divide that by the third term. And so that's going to be divided by 12. And all of that will equal sine of a. And so if you think about the previous ones we did with the law of cosines, like let's just go back and look at this. Whenever you had something equal to cosine of b in this example, we had to flip it and do the inverse. And then we did the inverse of that and we got directly to the answer. So the same thing happens even if it's sine. So this is set equal to sine of a, and I know it looks crazy, but remember, you can type all this into your calculator and it be one number. And then you can do the inverse sine of the answer. Since we're using graphing calculators, you can always just type in a and s, and that gives you pulls down the answer from the previous one. But yeah, that's basically what we're going to have to do here is the inverse sine of all of this. So it looks ridiculous, but that's because I refuse to use rounded numbers when I'm trying to figure something out. So just to kind of recap again, I'm using this in place of a rounded number, and then I'm using all of this in place of another rounded number, because like I said, you could type this into your calculator and get an answer and then do inverse sine of that answer, and your answer would be very close to, but slightly different than what I'm going to get here. So by doing all this, you're not rounding until the very end, which is what I prefer to do because I'm going to get the most accurate answer. So like I said, I know it looks crazy, but we're going to get the most accurate answer here. And so typing all that into my calculator gives me 73.617 degrees. Okay? And so don't worry. Finding angle C is going to be easy because once you know two of the three angles, you know they all got to add up to 180, so just subtract it from 180. So subtracting those two from 180 gives me an approximate angle of 56.251 degrees. And so that's it. So I'm sure y'all felt pretty good about the first four examples, but this one was kind of crazy. It is crazy when you're asked to solve for multiple angles, I'll admit. But hopefully it made sense along the way, and hopefully you didn't watch this video on mute. But thank you for watching, and like and subscribe if you want. Goodbye.